Hello and welcome to this video about the square roots of matrices. In this video we'll look at the derivation of the formula for the square root of a 2 by 2 matrix so that we can get the square root directly from the entries with no need for eigenvalues or eigenvectors. We'll firstly define the matrix to be a 2 by 2 matrix with these entries. Then we'll set B to be the square of matrix A, and these will be the entries for it in terms of the entries of A. We'll then set the entries of matrix B to also be these entries so that we can work in reverse to find the entries of A in terms of the entries of B. And these are the equations that describe the entries of a matrix that is the square of another matrix. We can also set K to be the determinant of matrix A, which is equal to this in terms of the entries of A. And this is what the determinant is in terms of the entries of the square of matrix A. We can take it for granted that it is the square root of the determinant of matrix B. We can then number these equations to be used in the derivations. Now we have to manipulate these equations so as to get A, B, C and D in terms of the entries of matrix B, which are E, F, G and H. So now to start deriving the formula for the square root of a matrix, we'll add these equations together like this to make this equation, which we'll further manipulate to make equation 7. We'll expand the brackets. Then we'll simplify this expression. We can then factorize it to be this. So we can get the square roots of both sides and write this equation out like this to use later. And then we can subtract these two equations. We can then expand the bracket, which will swap some of the signs. Then we can simplify this expression to get equation 8. We can then divide these two newly found equations to give us this expression, which we need to work on. We can then factorize the numerator to give us this. We can then simplify this expression to give us equation 9. Then we can add these two equations together. We can gather everything here over the same denominator. And then we can cancel out these two variables and gather like terms together to give us this. Then we can eliminate the 2's to give us the variable A. So this is what A is in terms of the entries and the determinant of the squared matrix. We can calculate variable D in a similar way. Now to calculate variable B, we'll divide these two equations to give us this. We can then simplify this expression to give us B. We'll rewrite this equation out like this to give us B in terms of the entries of the squared matrix. Then we'll finally get the last of these entries, C, in a similar way to getting B. So here are all of the entries of the square root of a matrix. We can easily program a computer to find them, but we need to expand it to complex numbers if the number under the square root signs is negative. We can set this variable m to be equal to this to try to simplify the math, because this expression turns up a lot. So this is what these equations are now if we include this new variable m to stand for this expression. We'll write out these entries of A in terms of the entries of B. We can take this number 1 over m out of the matrix like this to help simplify this matrix. We can simplify these fractions like this. We can then write out what m squared is, and further simplify this matrix. And the 2's cancel to give us this. Then we can write this matrix out like this, which makes it look extremely simple to write out. So I decided to write up some computer code in JavaScript to test this formula. This function calculates the entries of the squared matrix in terms of the matrix being squared, according to the names of these variables that are used in the derivations, in equations 1 to 4. This function calculates the square root of a matrix. It calculates these variables k and m first. K is the determinant of the square root of a matrix in equation 6. M is described in the derivations in equation 14. And these are the equations for the entries of the square root of a matrix given in equations 15 to 18. They have a 1 on the end because I want to store them in different variables so that I can compare them later. These functions print out the matrices and the variables k and m onto the screen. This function tests whether two matrices are equal. These matrices are stored in the variables a to d and a1 to d1. I'm using a Boolean variable which is set to true initially. So I'll get the absolute value of the difference between these two first entries of two separate matrices. And they have to be very close to each other, otherwise their values are printed out. They must not differ by a millionth. Then this function will return false, saying that these two matrices aren't equal to each other. And then this function will compare all the other entries of these matrices, since all these entries must be equal. So we'll return the value of the boolean which is left unchanged. So we're returning true here. It is best to leave it as a variable, because the function could be changed to compare matrices with a lot more entries. Now to put all of these functions together into a testing function, we'll print started test on the screen to let us know that this function has been invoked. We'll test it 10 million times. That's how fast JavaScript is, and it's an interpreted language. We'll make up a while loop to create the first matrix. K will be the determinant and must be greater than 0.2 to leave the loop. It'll be set to 0 so that the loop may be entered the first time. So we'll get all of the entries. They'll all be positive numbers and non-zero. Then we'll calculate the determinant. Its value must be positive, or the matrix has to be calculated again. The condition is that the determinant must be greater than 0.2, which is stronger than being positive and non-zero. This loop looks like it could in theory go on forever, but I'm still able to invoke it 10 million times. Don't test it this many times unless you know that it works. Otherwise the program will continue for a lot longer and possibly produce a lot of output. This square root function won't work for matrices that have a negative determinant, or possibly negative entries, because this means that it'll have negative eigenvalues, and so be a complex matrix. And this program isn't able to do this yet, though it could be expanded to do complex numbers. So I'll get its square and put it into another matrix, and get the square root of this matrix and put it into still another matrix. Then we'll compare the two matrices, and if they aren't equal, then we'll print out an error and print out all of the information. And then finally we'll write out the message that we've finished the testing. So I hope that you have found this video to be helpful and interesting. Please click like and subscribe if you did. Please leave some helpful thoughts in the comments. Feel free to share this video, and thanks a lot for watching.